Let's learn about RSA. The RSA is a public key cryptosystem used for secure data transmission. RSA stands for Rivest Shamir Adleman, which are the name of the scientists who were involved in creating this system. There are other cryptosystems such as AES and DES, but they use same single key for encryption and decryption, which we have seen earlier as well. Remember the first few encryptions and decryptions examples we saw using Alice and Bob. They use the same single key for encryption and decryption. However, these are not very secure, because if there is someone like Eve who is sniffing through the transmission of data and gets hold of the key, then he can use the key to decrypt the data and obtain the plain text. So, how can we overcome this?
Well, one way is to meet the receiver in person and give them the key. This will prevent someone like Eve from getting the key, as the key isn't transmitted along with the encrypted text through the wire anymore. But that cannot be done in all cases. So, what we can do is use two keys, which is what RSA actually does. The two keys are public and private keys. As the name suggests, the public key is public and it wouldn't matter if an intruder gets hold of this. However, the private key should only be shared between the sender and the receiver.
Let's take Alice and Bob as examples to understand it better. Consider Alice wants to send a plaintext to Bob. If we were to use the RSA technique, then Alice and Bob both would have a public key and a private key that are mathematically linked to each other. The public key may be known by Eve and it wouldn't matter, as it is public. So, Alice knows Bob's public key and Bob knows Alice's public key. Now, Alice would encrypt the plaintext using Bob's public key and send the encrypted data. However, in order to decrypt the data, the matching private key must be needed, which means Bob's private key. Even though the keys are mathematically linked with each other, they cannot be derived from each other. That is to say that, even if you know someone's public key, you cannot derive their private key from it. So, Bob would use his private key to decrypt the data that was encrypted by Alice using Bob's public key.
If we take the example of a mailbox, then we can think of the public key as the receiver's address, which may be known by anyone to drop a mail into the mailbox. But only the owner of the mailbox would have the key to the mailbox that can be used to read the mails. So, the mailbox's key is the private key in this case.
We can also use colors as an analogy to understand this concept in a better way. We know that mixing two different colors gives a unique color, but the same unique color can be obtained by combining several other colors. So, if we only have the unique color, it is almost impossible to know which two colors we actually used to obtain it. We can use this concept to understand RSA.
Consider Alice and Bob both have a starting color yellow. This will be their public key. Next, they would randomly select a private color, which are of course like their private keys. Now, they would mix the public color with the private color in order to disguise their private color. This will give us different colors. Now, Alice keeps her private color and sends her mixture to Bob. And Bob keeps his private color and sends his mixture to Alice. Now, the important trick is that Alice and Bob add their private colors to the other person's mixture of colors. This will reveal a shared secret color. Notice that Eve is unable to obtain this secret color, even though he could access the public colors or mixed colors, and that's because he would need one of their private colors to do so. And of course, he cannot know the original colors just by looking at the secret color, as there can be many combinations of colors that would produce the secret color. And that's how RSA works.
Those were some analogies that we used to understand the concept. Now let's understand RSA using some mathematics. The security of RSA is based on the fact that it is easy to calculate the product n of two large primes p and q. However, it is very difficult to determine only from the product n the two primes that yield the product. This is similar to how we learned earlier that the original colors can't be known from the secret color.
So, as a starting point, Alice and Bob agree publicly on a prime modulus, p, and a generator, g. Both should be a prime number. Let's consider 17 and 3 respectively. Then, Alice selects a private random number, say 15, and calculates 3 to the power 15 mod 17, and sends the result, 6, to Bob publicly. Then, Bob selects his private random number, say, 13, and calculates 3 to the power 13 mod 17, and sends this result, 12, publicly to Alice.
Now, the important trick is that, Alice takes Bob's result and raises it to the power of her private number to obtain the shared secret, which in this case is 10. And Bob takes Alice's result and raises it to the power of his private number, which would give the same shared secret number. Without their private numbers, Eve wouldn't be able to find the secret number. That's how security is ensured using this technique.